Hi, my name is Joycelyn Etheridge, and I'm a program manager on the Complex team. And thank you for coming or attending the Countdown 99 Complex Cluster Support presentation. I would like to begin by talking through our agenda. Today I want to talk about the availability goals that we were trying to achieve with complex clusters, the current technology that we have, and we're going to move through as to what support we will be adding in Complex. Again, one of the top issues that the field has been raising is how do you do setup? And I'm going to talk through that in pretty great detail this morning, as well as putting it all together and what the final conclusions are on how to set up Complex for cluster support and provide more high availability for your application. So let us begin. The availability goals that we were trying to achieve with Complex have to do with four areas really: the application model, the client model, the data state availability, and the overall service availability. In the application model, the things that we were really concerned with, is your application protected through a transaction? And in addition, do you have compensation for that transaction of work so that you can undo things that you have done? The second part, when you talk about clusters and high availability, the thing is, our cluster model is really based on the retry scenario at the client. So the client is really not totally a part of the cluster as much as it is using a retry algorithm so that you can now get back to available sources. Again, failures should be, we're going for the goal of failures being transparent to the client, so that if a failure did occur on the back end, and the client would not have to know about that failure. And moving forward with the data and state availability, both SQL Exchange, Microsoft Distributed Transaction Coordinator, and a number of other products are now taking advantage of the cluster so that we have basic failover, which would mean that your data would always be available, as well as we will be making sure that we didn't have data corruption. So those were the goals. And lastly, is to make sure all the services available on the Windows 2000 platform would always be available. So with the cluster scenario, we wanted the availability of services to be one of our top goals. When we start talking about Complex support, we had a couple objectives, and that was to maintain feature parity with what we provided you with NTS 2.0 on the Windows NT 4 platform. And in doing so, we have done that, which means that we use a basic replication model, and all your applications would actually have to be installed on all the systems within the cluster. In addition to the services, we will be providing basic failover. Another goal that we went after for the Complex was to have a simplified setup. And in doing so, we created what is called a Complex wizard, which would actually cluster all the Complex services that will be cluster aware in this release. And then the other two questions that we've been getting a lot is, what happens if MSNQ is on the machine? What happens if SQL Server? And I will talk through some of those issues, as well as alert you to some white papers that are being written, which talks about the integration of Complex, SQL Server, and Microsoft message queuing. And the last thing that we wanted to focus on was that the use of clusters did not change the Complex programming model. And that's the one thing that we wanted to be really clear about, is that just because you're now adding clusters, we didn't want you to feel like you had to change your programming model. So I want to go through some of the assumptions that we have and the things that you should be aware of as we deliver Complex to you in the Windows 2000 timeframe. Complex will always support homogeneous clusters, and what that means is that we will not support the combination of a Windows NT 4 cluster with a Windows 2000 cluster. And we do not support the concept of rolling upgrades, which is what the Windows 2000 cluster Wolfpack will be supporting. And rolling upgrades means that we will require you to actually take down the cluster and then upgrade, instead of having your nodes constantly up at the same time and rolling from Windows NT 4, say for instance, up to Windows 2000. The multi-node cluster support will be for Complex will be supported in the Windows 2000 Data Center product. And when you're talking about Complex applications, in order for them to participate in a cluster, they will have to be installed on both nodes of the cluster, or once we deliver data center, all nodes of the cluster. And the complex replication is the way that you will replicate the configuration data throughout the cluster, and you use that through the component services admin. Now we're talking about a new and complex services cluster support. With MSDTC, we actually have refined the setup for that and included it as part of the cluster wizard that I talked about earlier. The basic functionality is that you will have one service of MSDTC that runs throughout the entire cluster, which means you have one TM, and then you will have proxy on both nodes, or when we get to multi-node cluster, on all other nodes of the system. In essence, what this means is that DTC looks like and behaves as if it's running in an active scenario for the Wolfpack cluster scenarios, but in essence what we're really doing is having a proxy service, and that's really talking to one TM that happens to be cluster wide. Another service that will be cluster is complex load balancing, and Carl talked about that a little bit earlier. We're providing basic failover through the complex component load balancing router, and what we do is make the load balancing router a resource up under the Microsoft cluster server, or Wolfpack, and there you will have basic failover. So if for instance, if something happens to the router, then it will fail over to another designated router within the environment. Queued components, we have not really ironed out our full queued components scenario for the release of Windows 2000. We are working on that at this point in time, so we don't give up hope on us. We're still trying to pull that one together. And with IMDb, we will have a white paper that will talk about how you can support the current IMDb within a cluster. Today, with what we're releasing with Windows 2000, there is really no way to do, or no reason to do, cluster support, because IMDb is really a local system service only, and so that you can never have a remote call to it. When we're releasing the next version of IMDb, we will have coherent caching between two IMDbs, and at that point in time, we will have a cluster solution for it. Now, I wanted to talk to one of the hot issues that has been constantly raised is about setup, so I'm going to just dive right into the whole setup scenario. The new Complex Cluster Wizard, it basically does the following. It will create a Microsoft MSDTC resource as well as the load balancing resource within your cluster environment. With MSDTC, it will create a resource in what we call the default resource group for cluster, where you have an IP name and a disk name. It also moves the log file to a shared disk within the on the cluster, on the quorum disk, as well as mark the necessary registry keys, which actually tells you where you can find, for instance, the registry. In addition, we will have the complex load balancing service, and we will be marking that as also as a cluster resource, and it sets up the router node for failure, and again marks the appropriate registry keys. Now, we will not have a GUI version of the Complex Cluster Wizard, at least that's not currently in our plans. There is a possibility we may get to that, but you can find it in the Beta 3 under the System32 directory. It's called ComClust, COMCLUST.exe, and it will be located there as well for RTM. Now, some of the details that you may want to know about is that when we talked about Microsoft DTC, that is going to be probably your biggest legacy when you move from the Windows NT 4 environment to the Windows 2000 environment. You'll have this with MTS 1.1 as well as MTS 2.0, which is where we really started to support the full clusters. Now, in the scenario, I wanted to make it very clear that we will not be supporting the rolling upgrades on the Microsoft cluster. And one of the reasons is that in the earlier versions of Microsoft DTC, we actually had maintained two log files, and one was called the XATM log file. We have now merged those in Windows 2000 into one common log file, as well as we've changed what we call the whereabouts, which tells you exactly where to find the TM. And that algorithm, that format, network format has actually changed, so those things preclude us from being able to provide rolling upgrade support. But in the future, after we release Windows 2000, we will be providing rolling upgrade support with the next versions of COM+. So another area is changing the location on the MSDTC log file on a Wolfpack cluster. With Beta 3, there's currently a bug that you will find in there. You have to make sure, we do not stop you, for instance, of putting the log file on a non-shared disk within the cluster. So just please be aware that you will have to make sure that you have moved, if you do choose to move the log file, that you move it to a shared resource. And I talk about how to do that in the slides, which will be available to you, which means you basically have to stop the Microsoft DTC service. You right-click on My Computer and select Properties, and then you select the MSDTC property page, and under Log Information, it will allow you to move the log file. Another thing that came up too was how do you reinstall? In a scenario where you already have a clustered MSDTC, you will basically stop the cluster, and you will use the cluster administrator, for instance, that will both stop Microsoft DTC as well as any other services that depend on MSDTC, such as CommTI or message queuing. You run then the commclust.exe from the System32. And one of the key things that you will need to do in this release, especially if you're coming from MTS 2.0, is that you will have to open up the registry, and we will address this later, and you'll have to look what is called the master node for DTC. And basically what the master node does is it points to where the actual TM is installed, which node the TM is installed on. And here you will use from HKey local machine, you will click on cluster, and then you'll click on the resources. You can just use the find key to look for distributed transaction coordinator. And from there you'll see join master. The name join master will actually display to you which server within your cluster has the master for MSDTC. And at that point, that's where you would run commclust.exe. And you have to run commclust.exe for Beta 3 on all nodes on your cluster. With RTM, we will actually have a scenario where you run it once and it will set up for the entire cluster. After this, you just reinstall any services that then depend on Microsoft DTC. The next 3 slides I'm going to skip through because they're actually just a little bit more detail. And I want to start talking to you a little bit about Wolfpack and actually how these complex applications will behave within the Wolfpack environment. In talking about that, I'm going to talk about the Wolfpack architecture. And here you just have a client group of PCs, and I'm sure you're quite familiar with this, where you have server A, server B, and you really have shared disks within the environment, and I won't belabor that. In the scenario that we looked at is that you actually have the concepts of a cluster-wide name as well as a virtual server name. And what we suggest that you do from the complex environment is that you set up your co-create instances to actually go to the virtual server name. That'll give you a little bit more granular way of getting to the resources within your particular environment. If you do the cluster-wide name, you'll still get to your same resources, but you actually have to go through the network naming it to get to the right services. Now, what happens with complex components during failover? Basically, we have the server components where the server components actually become invalid, for instance, if there is a failover. And what this really means in the complex environment is that since everything is pretty much protected by a transaction, you will probably go into recovery mode. And at that point in time, the client will actually have to do a new co-create instance and begin again. So what we're basically saying is that using the transactional components within COM+, you basically will protect you will protect your data, and the client will just restart again using the same retry mechanisms that we were just talking about, and then you can continue on. Now, what that does in the time frame is that it allows the the server that has failed then for the failover to occur. And so MSDTC and the complex load balancing services will automatically just fail over to the new lose services, and then you can just begin again. Now, if you have SQL Server, you may notice that SQL may take a little bit longer. So when you're starting to write your application, you may want to write your logic within the client so that you have enough time to account for the longer delays in the services coming back up within the environment. And the thing here to remember is that all of this is based on pure client retry, and that is the main mechanism here. So we actually expect, we're really providing basic failover so that you are able to just begin again. Now, one of the things, another component that we wanted to talk about is the integration of, for instance, Complex load balancing, the Microsoft Windows load balancing system, and the Wolfpack scenario. And what we wanted to talk about is that you actually have three cluster technologies today that are not integrated. But actually, you can provide an integrated solution to your customers with these three. And the main way of doing this is that if you look at the screen here, you have a web client that potentially is coming across the internet, and it goes into your Windows load balancing server, which is really basically IP failover. And then the next tier is really where the complex load balancing scenario comes in, because here you have at what we call the application clusters. And then using the load balancing scenario that Carl talked about, you're able to do co-create instance against your component load balancing router. It will then just delegate or instantiate the components on a different server based on the component load balancing algorithm to the what I like to call the least busy server, or the server that can give you the most performance. From there, you look to the next level, which then you have your back-end services where your database, for instance, in MSDTC, is also clustered through the Wolfpack scenario. And for here, you have full availability of your services. So what we're actually providing you with the combination of these three services is availability of all the services within the environment. Now, I wanted to make this clear that we're not saying that the state, we're providing you consistency of state or state availability, but we are protecting you through the use of transactions from data corruption. And I won't go through a lot of detail with the load balancing, but the key here is that when you're using the Convoy technology, the Microsoft load balancing services, basically all the servers within WLBS, or NLB, actually I think is what it's called now, all receive the same IP request, but based on an algorithm, only one server will actually respond to the request. Now that is very complementary, because then that request then gets moved to or passed to, for instance, the complex load balancing router, which gives you a finer grain for then delegating or forwarding your co-create instance to the appropriate server. So now you're able to compose your applications as if they were not in a cluster, but they get to take advantage of the failover and availability of the cluster. And the key here is that you have the same programming model. But the thing that I do want to caution you about is that you do have to be careful about state management for this. So just to reiterate what I've said is that the application are really, it's just a collection of COM classes, and they're installed on a number of application servers. And when you think about an application cluster, it's just a collection of servers, and the load balancing server really routes all of those requests to the appropriate server. And the clients basically install the applications from the application server, and they pass on the co-create instance to the component load balancer. And the nice thing is that the routers actually, from a networking load balancing scenario, provides you a mechanism so that you have IP failover, and so that if there's any one server within the environment that is down, the client never knows this.